Connections of resistors. That is what is the topic of our today's video. So hey, what is up people, this is Devyansh and welcome back to my channel Learnium, where we learn and discuss with a lot of fun. Now let's begin. Okay, so most of the time we use number of resistors in our circuit. Now there are mainly two ways of connecting the resistors in our circuit. So let's talk about the first way. So that is the series connection of resistor. So as the name suggests, like they are in the series. It means that one after the another. So we have one resistor, then after that another one, and we can continue this. So when we have one after the another, we call that connection as a series connection of resistors. Okay, now let's talk about the another way, and that is the parallel connections of resistor. So again, as the name suggests, they are parallel to each other, right? So that connection is the parallel connection of resistors. Now we are going to talk some more things and some interesting things about such connections. So let's see that. Okay, so now let's try to do one activity and we are going to make one conclusion out of that. Okay, so let's say that we have a battery with voltage 6 volts and we have 3 resistors with the resistance 1 ohm, 2 ohm and 3 ohms. Okay, now let's connect these 3 resistors in a series connection. So you can see this is how it's gonna look. Now let's also add ammeter to it so that we can get the value of current also. Okay, so with all this, now let's allow current to flow. And here what we can see, yes, all the ammeters are showing the same readings. It means that throughout the circuit our current is constant. And what's the value of current? Yes, it is 1 ampere, and after some time you will understand that why the value of current is 1 ampere. Okay, so we have seen that current is constant. Now let's see what is the values of voltage. So let's take our voltmeter across our first resistor. What we can see? Yes, the value of voltage is 1 volt. Okay, so what we can say, that our V1 is 1 volt. Okay, now let's take our voltmeter to our second resistor and let's see the value. Okay, we got the value as 2 volts. So our V2 is 2 volts, and we can do the same with our third resistor and we will get V3 as 3 volts. Okay, so we have V1, V2, V3 as 1 volt, 2 volt and 3 volts. Okay, so now I'm not sure that whether you have seen it or not. So here we have that V is equals to V1 plus V2 plus V3. Now recall that we had the battery of 6 volts. So on the left hand side we have 6 volts and that is equals to 1 volt plus 2 volt plus 3 volts. And here you can see that they both are equal, right? So what we have, that V is equals to V1 plus V2 plus V3. Okay, so we have seen some interesting things here, but now right now one doubt you might have, that is that, see what we saw, that current was constant. Means if we have one resistor, so let's say some current is coming in and after passing through that resistor the same current is getting out. So what is happening here? Resistor is supposed to decrease the current and it seems like it's not doing its work properly. Well, I have already made a video on that, so you can check the I button after watching this video. Okay, so after all this we are going to do one more thing with the series connection. Okay, so from Ohm's law we know that V is equals to IR. Now we are going to apply Ohm's law for each resistor. Okay, so for the first resistor we have, yes, V1 is equals to I into R1, right? I'm hoping that you are getting it. Now for the second resistor we have V2 is equals to I into R2. Here we have already seen that current is constant and voltage and the resistance, they are different. Okay, now we have V3 is equals to I into R3. Okay, so we have 4 values here. V is equals to IR, and then the values of V1, V2 and V3. Now what we have seen before, yes, V is equals to V1 plus V2 plus V3. Okay, now what we can do, we can plug in the value of voltages that we have just find out from the Ohm's law. Okay, so here what we will get, yes, IR is equals to IR1, IR2 and IR3, right? We are just plugging in the values here. Now on the right hand side, what we can see, yes, we can take I as common. So we have I as common, and then in bracket we have R1 plus R2 plus R3. And now those two current will get cancel out each other, right? They will cancel each other, and finally we have that R is equals to R1 plus R2 plus R3, right? So we have reached to our final destination. But why we are trying to find this? So what we have done here, let's say that we have 3 resistors, 1 ohm, 2 ohm and 3 ohm. So what we want to do is that instead of having 3 resistors individually, we want to mix them up and we want to make them one single resistor, right? So what we have seen, that R is equals to R1 plus R2 plus R3. Now we have that R1 is 1 ohm, then we have 2 ohm plus 3 ohm. So finally the value of R is, yes, 6 ohm. So instead of having 3 resistors individually, we can mix them up together and we can replace it with a one single resistor of 6 ohm. So that is what we have done here. We have arrived to this equation so that we can use it when we want to simplify the resistance, right? So we will use this to simplify the resistance in the series connection, right? So what we have seen in series connection, current is constant and voltage will vary according to resistors. Okay, and finally we have got that R, or the total equivalent resistance, is R1 plus R2 plus R3, or the sum of all the resistance. Okay, so once we are done with that, now we are going to talk about parallel connection. But before I teach you about that, I urge you to think about it. Yes, you just try to think about that what will happen in the parallel connection. You just try to arrive at the equivalent resistance that we seen in the series connection. So it's my humble request to all of you, please try to think about it, and that is how we can make our concepts very stronger, right? So I'm hoping that all of you will try to do that. Now let me explain you about the parallel connection. Now let's again do the same activity. So we have the same battery with 6 volts and same 3 resistors with 1 ohm resistance, 2 ohm and 3 ohm resistance. Now, but the only difference here is that we are going to connect them in parallel, right? So now we have parallel connection of resistors. Okay, so again we are putting in the ammeters so that we can see the value of current. And one thing we can notice is that ammeters are always connected in series, right? And if you are wondering why, so I have already made a video on that. You can also watch that from the I button, but after finishing this video. And also voltmeter are connected in parallel. Okay, so let's allow current to flow here, and what we can see here, yes, the current or the value of current are different. Now why? Can you guess why? So look at that point over there. Now at that point the current has 2 paths to flow and current is getting divided. So some current will flow that way and the remaining one will flow that way. And again, and one more time we have the same condition, and again the current will get divided, right? So that is why the value of current is different in parallel connection. Okay, So what we can see, that I is equals to I1 plus I2 plus I3. Okay, and here the voltage is constant. So here you can see the value of voltage across every resistor. So can you see here? Yes, we have 6 volt, 6 volt and 6 volt, right? So what we have seen, in parallel connection, voltage is constant but current is different. Now can you guess that what we are going to do next? Yes, we are going to use the Ohm's law, right? So from Ohm's law we have V is equals to IR, and now we have I is equals to V by R. Okay, now let's apply the Ohm's law for every resistor. So what we have, for the first resistor we have that I1 is equals to V by R1, right? Here the voltage is constant, so every time we will have V as our voltage. So now we have I2 is equals to V by R2 and I3 is equals to V by R3. Okay, now we have this equation, I is equals to I1 plus I2 plus I3. Now we can plug in the value here. So what we have, yes, V by R is equals to, yes, you can see here. Now after that we can take common here. What is the common? Yes, on the right hand side we can take V as common. So we have V as common and 1 by R1 plus R2 plus R3 as in the bracket. Okay, so now again here those V will get cancelled out. So finally what we have, yes, 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So again we have arrived to equivalent resistance but in parallel connection. Okay, so if we have 3 resistors in parallel, 1 ohm, 2 ohm and 3 ohm, now we can replace these 3 resistors with 1 resistor. But for this we have to use this equation that we have just arrived to. Okay, so what we can see, 1 by 1 plus 1 by 2 plus 1 by 3 is equals to 1 by R. Okay, now let's take the LCM here. 6 is the LCM, and now we can do very simple calculation. So here we will get that 1 by R is equals to 11 by 6. Now let's do the reciprocal on both the sides. So what we will get, R is equals to 6 by 11. So what it means, that we can replace these 3 resistors which are right now connected in parallel with one single resistor of resistance 6 by 11 ohm. Okay, so that is what it means. So here we have seen the equivalent resistance of the resistors in series and resistors which are connected in parallel. So both we have seen here. Okay, so now it's a summary time. So let's revise all the things which we have seen in this video. So in the series connection we saw that current is constant but the voltage was different, right? And after that we arrived at the equivalent resistance, which was that R is equals to R1 plus R2 plus R3. And for the parallel connection we saw that voltage is constant but the current is different, and the equivalent resistance was, yes, 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So that were the equivalent resistance of both the connections in series as well as in parallel. So that's it for this video. I hope that you understood everything. If you have any doubt, you can comment down below, right? So I hope that you enjoyed it. If you really did, then don't forget to hit the like button and please do subscribe to my channel for such more informative videos. I'll meet you in our next video. Till then, thank you very much for watching.